Hello everyone, welcome back to Let's Unbound. Yes, we are in 1.3 of AP Precalculus journey. So, as usual, we will have a quick concept overview plus 3-tier problem solving. Here we go for rate of change in linear and quadratic function. So, let's get into the topic without any delay and be ready with your pen and paper and also calculator. So, we know what is rate of change, right? Change in vertical change by horizontal change. Now, let's understand a linear function and quadratic function first. What is linear function? It will be of the form f of x is equal to mx plus b. So in this structure, a linear function will look like this. Why I particularly use m here is the coefficient of x will be the slope. Slope is nothing but the rate of change for a linear function, and it will be a straight line. The quantity increases fully or decreases at a steady space. So it won't change. The rate of change will be constant. Then concavity of a linear function is not applicable to this because it's a straight line. You can't see a bending over here, right? So very simple. What is how linear function looks like and what is the role of slope? That plays very important role, and the graph will be a straight line. It will be throughout increase or throughout decrease. And concavity not applicable here. So this is a parent function. Many functions I can make. This is a parent function of a linear function. So with this you multiply 2, you got 2x and add something plus 5. So this will be, we can generate many functions, linear functions, right? So yeah, now let's move to quadratic function. Quadratic function will look like f of x is ax square plus bx plus c. And here, one important thing, rate of change is not constant here. Every place, the rate of change will be different. So from here, if you find rate of change, I mean slope, you draw tangent line or a secant line, it will have different slopes, right? I draw 3 of them. Clearly different slopes, so rate of change is not constant here. And the graph is called parabola, a U-shaped curve, maybe upward facing or downward facing. So when it will face upwards, when A is positive, it opens up. In our calculus language, we will say concave up. And what is concave up means? The rate of increase is increasing, right? So the rate of this, you find the rate will be increasing. If A less than 0, it opens down, we will say concave down. Here, that means rate of increase is decreasing. So it will be something like this. So if you find the rates from left to right, it will be on decreasing manner. Okay. Then one important thing, rate of change is not constant, but the way the rate changes is, it will be constant change. The rate changes linearly. So the thing is, average rate of change will be different. Okay, you find A or OC for different, so it will be of different values. But how these values changes, that will be a constant change they will have. For example, if your ARC is 3, 5, 7, 9, so the way the AROC different, right? Average rate of change differs the same. They differ by 2. So this is what they say, rate changes linearly, right? This is the important point and we will get easily confused here. So take a time, pause the video and understand this. Okay, now we can move to average and instantaneous rate of change for linear function. In linear function, average rate of change is equal to instantaneous rate at any point. Okay, and it will be equal to a slope of the line. Very simple. So we don't want to do two different rate of change here because it's a constant rate of change, right? That's why. But in quadratic, as we said, it will be differing. So average rate of change is like 2 points will be given to you. For example, this is a comma f of a, this is b comma f of b. You just apply the slope formula, y2 minus y1, x2 minus x1. So this is x1, y1, this is x2, y2. Basic slope formula will hold, right? Instantaneous rate of change, I hope you remember like what we did in previous video, right? So a parabola, you need the slope exactly at this point. Okay, so here you need to pick one's very clear nearby point. Okay, only one point is given. Maybe like this is x is equal to a. Then I should pick, like if you get closer into this, it will appear to a straight line. So like this is a point, I pick a point here. Okay, so of course it won't be touching the curve, but still for estimation we took in that way. So x is a, and another point. So a comma f of a is the one point, and another point would be A plus very closer, I use del x. A plus 0.0001 and f of that value. So now you can apply the slope formula again. So that will be f of a plus del x minus f of, right? So that's simple. And we are moving to next. So the rate changes linearly. I have explained this. Why this statement is, we are telling rate changes linearly in quadratic function. How? So x is 1, 2, 3. This is a quadratic function. F of x is this. So let's find AROC for 1 to 2. Okay, x to x1 means, so x is 1 means for x and 2 we are doing this. For 1 and 2. So how will you do this? F of 2 minus f of 1. This difference. And you divide it, it's 3. Same, you do AROC for 2, 3 and 3, 4. Okay, so if it's 4 means this will be 16, right? So if you do this, and we got average rate of change. This is rate. Now, how this rate changes? Rate changes, how? Let's see. So 3 to 5, 2 added. 5 to 7, 2 added. Okay, so if you do this, it will be always 2. Right? So that's why we say quadratic function, the rate changes linearly. Got it? Right. So now final summing up. So function type 2 we will deal here, linear and quadratic. Both are same, AROC and IROC. Average rate of change, instant rate change. But quadratic, it will change across intervals. Also, if you do at a point, we have to approximate this using taking small intervals. Right? That's the basic concept. Now, let's move to question 1. So this is based on table of values. Just a second. The table over here. Okay. The table gives values of the function g for selected value of x. If the function g is linear, what is the value of g of 12? Okay, so let's see how to solve this. I need g of 12, right? So when x is 12, then you will get g of 12. So you just extend the table. It's linear function. So linear function, which wherever you find slope, it will be same. So I'm going to find slope using 2 known values. And I also should connect the unknown values I have. So I'm going to do the slope like this. Okay. So if you apply slope, change in y by change in x. Right? So 6 minus 22 by 6 minus of minus 2 using these 2 points. And here, equal to g of 12. Okay. Right. Let it be g of 12. Or you can put some other variable. So g of 12 minus 6 by 12 minus 6. And simplify, you will get g of 12. So 6 minus 12, 22 is minus 16 over 8. G of 12 minus 6. 12 minus 6 is 6. So minus 16 by 8 is 2. Right? Minus 2 equal to g of 12 minus 6 by 6. And start simplifying. This 6 will get multiplied. Minus 12 is g of 12 minus 6. And the minus 6 will move here. Minus 12 plus 6 equal g of 12. That's it. You got your g of 12 is minus 6. Okay. So my g of 12 is minus 6. That's it. We find it. This is a basic level 1 application of the concept. Right. We are moving to second question. The average rate of change of a function f is plus 4 on the interval 0 to 3, plus 2 on the interval 3 to 6. What is the average rate of change of f on this interval? Okay. Previous question, they give some table values. They said it's linear function. And here we need to find average rate of change with these given. And one more thing, they said if the pattern continues. Right? So let's see how to solve this. Okay. Let's make the table of let's make 0 to 3. 0 to 3, then 3 to 6, 6 to 9, 9 to 12. So because I can see clearly the width of the interval is 3, right? That's why I continued this way. 12, 15. So you should make sure the length of the interval is same. Now, f of x would be, okay, actually f of x we don't know, but average change we know, AROC. So you write AROC. Average rate of change between these two, 0 to 3 is 4. 3 to 6 is 2. And they say this pattern continues. We can analyze the pattern. It's subtracting 2. So that will continue. So the pattern is subtracting 2. So subtract 2, this will become 0, subtract 2, minus 2, subtract 2, minus 4. And yeah, we got, so 12 to 15, it would be minus 4. So final answer, average rate of change of F in the interval 12 to 15 is negative 4. Right? Again, a simpler question. So, the concept is same, just you need to find what could be the approach, how to start, where to start, right? Okay. Now, next one, question number 3. A function f is defined by quadratic expression. Values of f of x are given in the table. Now, is the rate of change of f of x constant? Justify. Identify the interval where the function is increasing and decreasing. Over which interval is the rate of change greatest? Does the function appear concave up, concave down, or it has both? Fifth one, find the rate of change from minus 3 to minus 1, 1 to 3. Okay, so they said it's a quadratic expression, right? And 5 subdivisions, and they give the table values to us. So let's analyze every question in deep. Is the rate of change of f of x constant? Okay, so find rate of change. But still, they said quadratic expression. So that's a very big clue they have given. So I can say no, for a quadratic function, rate of change will not be a constant. Okay, so, and also you can, if you want to check, just pick 2 of them, find the rate of change. For example, here, the difference is 1 everywhere. Horizontal difference, right? Horizontal change is 1. So they give it in proper way. So easy way. 5 minus 12 is minus 7. Here, minus 5, right? So the average rate of change is not constant. So the answer is no. And justify, because it's a quadratic expression, or you can take some values and prove this. Okay, minus 7 and minus 5, or the 2 rate of change, they are not constant. Okay, they differs by value. Second one, identify the intervals where the function is increasing and decreasing. Table of values, you don't want to check A or OC, right? They are just asking function is increasing, decreasing. So from negative 3 to negative 2, negative 1, 0, 1, 2, 3. It's negative 3, it's 12. Negative 2, it's 5. Negative 1, it's 0. 0, it's negative 3. Something is going down. We can see that, right? Then after minus 3, it goes still below. Sorry, it's not a straight line. So something like a smooth curve. Minus 4, and then minus 3 is increasing. So it goes like this, right? So decreasing for till this, right? So minus 3 to 1, it's decreasing. Minus 3 to positive 1, decreasing. And after 1, 1 to 3, it's increasing. That's simple, right? Now, moving on to third question. Over which interval is the average rate of change is greatest? Okay, so let's find AROC. Minus AROC for minus 3 to minus 2. The difference is 1, right? So horizontal difference of the intervals. Just vertical changes 5 minus 12, which is minus 7. So basically, you just find the difference. That will be the average rate of change. 0 minus 5, minus 5. Minus 3 minus 0, minus 3. Minus 4 minus 3, minus 1. Right? Minus 3 minus of minus 4 plus 1. 0 minus 3, 3. So this is minus 7. Okay. So here we don't want to work out as x is changed in a unit difference. So you can just find f of x differences. Right. So minus 7. So minus 7, minus 5, minus 3, minus 1, plus 1, plus 3. And I can see the difference is greatest. Average rate of change is greatest here. So what is that interval? You have to write f of x. So 2 to 3. Or you can mention like this. Open interval is fine. Is the has the greatest rate of change. Greatest average rate of change. Right? That's simple. And moving to fourth question. Does the function appear concave up or concave down? So we already did the decreasing, then increasing like this. Right? So it's a concave up category. Decrease and an increase. So it is, the bending is cup shape, so it's concave up. Very simple. Concave up as the rate of change is decreasing to increasing manner. Right? Next one is fifth question. I think we are in the last part. So this is the easiest topic. Find the average rate of change from -3 to -1, 1 to 3. We already did this for comparison, which is greatest, right? So we can pick from that, or, oh yeah, but actually we did for consecutive intervals. But this time I'm going to take this to this. Okay. So 2-unit difference, 1 unit, 1 unit. This you need to differentiate. So average rate of change in -3 to -1 is, you apply the formula way, 0 minus 12, then -1 minus of -3. So -12 by +2, which is -6. Right? Then AROC at 1 to 3. Same thing, 3 minus 1 to 3. So in denominator, 3 minus 1. Then this to this, 0 minus of -2, which is equal to 4 by 2, which is +2. That's it. These are the average rate of change in the particular interval of time. Okay, so that's it. And now, as usual, I have a bonus question to you. A stone is thrown upwards from the ground on its height h in meters after t seconds is given by this equation. You need to do two things. Find the average rate of change in this particular time. Interpret your result in the context of the motion. So how will you interpret the result? Right? So yeah, so that's simple. And if you got any decimal answers, you can just give it to 3 decimal places approximation. And yeah, if you have any other questions, you can drop them in comments. Thank you for joining today. We will be meeting in 1.4 video very soon. Until then, keep learning, keep practicing. Make sure you drop a comment if you have any queries, doubts, or if you got a different approach, right? If you want to join the student community of Let's Unbound, you can scan the QR code or you can click the link given in the description, right? Good work today. Let's meet in next video very soon. Thank you so much for joining today.